To get a better understanding of our rational functions, let's graph the basic rational function f of x equals 1 over x. Now we defined a rational function as f of x equals some polynomial p of x over another polynomial d of x. Here our polynomial p of x is just 1, while d of x is x. And we saw that these functions are undefined for x so that d of x equals 0. So in this case, our function is undefined when x equals 0. So now let's graph our easiest rational function, f of x equals 1 over x. Like before, to see the whole graph, let's start with some points. We can find these points by picking x values and evaluating f of x to get our y values. If x equals 1, then f of 1 is 1 over 1, which is also 1, giving the point 1, 1, which we can put on our graph. If x is 2, then f of 2 is 1 over 2, which is a half. So we get the point 2, 1 half, which we can also put on our graph. Now if we take a smaller value of x, say x equals a half, then f of 1 half is 1 over 1 half, which is the reciprocal of a half, which is 2. So we get the point 1 half 2, which we can also put on our graph. And if we take x to be even smaller, say x equals a quarter, then our function f of 1 quarter is 1 over a quarter, which is the reciprocal of 1 over 4, which is 4, giving us the point 1/4, 4, which moves even higher on our graph. Now if x gets closer and closer to 0, then our function f of x, which is 1 over x, gets bigger and bigger. For example, 1 over a tenth is 10. 1 over 1/1000th is 1,000. So we can use this to fill in our graph as it gets closer to 0. On the other hand, if x goes off to infinity, x is getting bigger and bigger, then 1 divided by x gets smaller and smaller, because the larger the number we divide by, the smaller our fraction is. So we can fill in the right-hand side of our graph as well. Our function gets closer and closer to 0 as x gets bigger and bigger. Now so far, we've only looked at positive values of x. But for negative values of x, we get a similar picture. But here, our function 1 over x is negative as well. But still, as x gets to be a really large negative number, our function gets really close to 0. And as x gets close to 0, our function still gets very large, just now it goes to negative infinity. So we now have the graph of f of x equals 1 over x. Notice here that as we get close to our undefined point, x equals 0, our function is going off to infinity and negative infinity.